So as people are joining, anybody have any just starter questions? We're probably going to do what we did last time. So if you haven't had a chance to look at 3.1 or 3.2 yet, we'll start the breakout room. Ron will lead that breakout room, and then I will lead the lab for this week. But just for starters, does anybody have any questions about last week's stuff? Just general R questions? Questions about the course? Doesn't even have necessarily about R. I will tell you for this week's lab, when you get to it, I am not going to have you make a notebook this week. So this week, you'll just be turning in your R script because we're going to work more with just the different data types. You know, you've got lists, matrices, vectors. And even though I'm going to guess for majority of you, when you think about working in R, you're probably going to be analyzing data. So you might say, well, why do I need to know how to work with a matrix? If you really understand how to, you know, call elements from vectors and matrices, and even lists for that matter, it will help you when you learn to manipulate data. And the reason for that is when we think about how data is structured, really, when we think of a single variable, that's similar to a vector. And when we think of a data frame, that's similar to a matrix. And so having those kind of fundamentals to rely on, I think really helps, you know, translate the things you're going to be doing when it comes to working with data sets. So that's one of the reasons I start here with these basic data types. The other thing is for your grades. So everybody should be able to go into the grade book to look at your grades and see any comments that either Ron or I have made. Just as a reminder, if you have any questions about the graded work, please do not post an additional comment on your graded work. The reason for that is Canvas doesn't automatically notify us of that. It sends me like a summary every couple days, and it can miss the comments sometimes. So if you ever have a comment on your grades, just send me an email, and that'll be the easiest way to make sure, you know, that I answer any questions that you have. The other thing is with the quizzes. So anytime that there's a quiz, you should be able to see your results immediately after the quiz. And it won't tell you what the correct answers are, but it should tell you which ones you get wrong. If you don't ever see that, let me know. There's a switch that I have to toggle in Canvas, but I can only toggle the switch after the first person takes the quiz. It's really goofy. But if that ever happens, just shoot me an email and I'll make sure that you're able to, after that first attempt, see what questions you got wrong. All right, so it is about 5 after. We're going to do the same thing we did last time with the breakout rooms. So if you're still working on 3.1 and 3.2, you're going to go into the breakout room with Ron. If you're working on the lab, you're going to stay here with me. So give me just a second and I will set those up. And then, of course, once you're done with the module 3.1 and 3.2 assignments, you know, feel free to leave the breakout room and come back into the main room where we're working on the lab. All right, so I have that open. You should see an invite now to join that breakout room if you're going to be working on 3.1 and 3.2. All right, so I've got everybody that's in here ready to work on the lab. All right, perfect. So for the lab, it'll be in the same place like last time. It'll be a module 3.3. So go ahead and open that up. And so there's going to be 2 goals with the lab that you work on today. One is just going to be more practice with matrices. Some of the things I ask you to do, you've already seen the code for how to do them. Other things, you might have to do a Google search to see, okay, how can I do this? So for example, there's one that asks you to make an identity matrix. I recognize that this is not a math class. So if there's anything that you come across that you think, I don't remember what, for example, an identity matrix is, just let me know and we can review those on the fly. Really, again, the purpose of this is just to see how to manipulate an object in R, specifically a matrix. And the reason matrices are useful is because they have both rows and they have both columns. And so again, we can think of data frames as being the same way. It's just matrices are a more simple version. So we're going to learn to manipulate those first. And then the second part of the assignment for the lab is I have written some code that plays a game of rock, paper, scissors. And what I'm going to have you do is I want you to look at this code. I've broken it down into 7 different chunks. And I want you to place comments for each of those chunks saying what it's going to do. Being able to read other people's code is, you're going to find as we move along, is a really important skill set. And the reason for that is no matter what I teach you in this class, once you're out there in the real world and you're analyzing data, there are going to be things that you want to be able to do with your data, but you're not sure how to do it. So what you're going to do is you're going to go to Google and you're basically going to Google, how do I do this thing with my data? And you're going to find somebody else's code that does that thing. But in order to use that code for your data set, you're going to have to know how to read that code and then how to edit the code so it works with your data. So we're going to work on that idea of being able to read code that you might not be familiar with, just to figure out what exactly is that code doing. And so that's what you're going to do in the second part of the lab. One thing that I do want to warn you though, is when you're working on that, you're probably going to copy and paste it over from the PDF. If when you go to save your R script, you get a question that's asking you about encoding, you're just going to choose the default option. What is happening there is the characters that are stored in a PDF are encoded different on a computer than they are in R. So you just have to convert that over. But that's a common problem you might see. And if that comes up, just let me know and we can look at that together. All right. Are there any questions before you all get started? All right, well then I will sit here and wait. And as you work on that lab and you have questions, let me know and we can share screen and troubleshoot stuff together. If anybody is just joining us, you should have the option also to join the breakout room if you're still working on 3.1 or 3.2. If you do not have that option, just shoot me a chat and I can place you in the room. And I will be right back. I'm going to grab some coffee.
Hey. Okay. Sorry I'm late. My car did not warm up as quickly as I thought it would. I have a question about the homework.
Oh, yeah. Go ahead. Is this a 3.1, 3.2, or the lab?
3.2.
I said I can go ahead and answer the 3.2. I also made a breakout room. So Ron is with people currently working on 3.1.2, but if it's just a quick question, we can go ahead and answer it in this room.
Okay. So for number 8, I just wanted to discuss if my understanding of why MATLAB changed the answer is correct.
Yeah, go for it.
Okay. So my thought is that the function was currently a vector, and then MATLAB turns it into a matrix, considering it's matrix laboratory. So that's why the answer turned from 4, which is like a total sum, to the column sums. Is that correct?
You're on the right track. I'm going to tweak it just a little bit. It's not so much that it changed the function from a vector to a matrix. It's just that it just changed the function, just in general. So whenever we download packages contain a bunch of functions within them. And so base R, which is what, whenever you first installed R, you've got all those base functions, has a sum function. But unfortunately, the MATLAB package also has a different function named sum. So it's just that the same name has been used twice. So when we load the MATLAB package, it overrides the original sum function. And so it's doing it a different way. And so it's more kind of, I put this in here just more kind of as a warning to just be aware that you can override functions. And it doesn't happen often, but occasionally you will find that some packages have functions that are the same name as other functions, and they'll get overridden.
Okay. All right. So, okay.
So that's why when you get down to step 9 and you run that detach, notice what that detach is doing is it's getting rid of the MATLAB package. So it's going to get rid of that sum function that went with the MATLAB package and revert back to the original sum function. Okay.
And, what was it? But when you upload the MATLAB package, it is giving the sum of the columns, right?
Yes, that is exactly right. Yep. Okay. That's exactly right. And it's not just the MATLAB package that has this problem. There are other packages that this will happen with. And again, it's rare that this is ever a problem for me. It's just more you want to be aware of it.
Okay. And why does that happen? Like, why does it sum the columns instead of just giving an overall?
Yeah, so it has to do with the fact that R is open source and that anybody can write packages and submit them. So one would hope that we would use different function names when we build new packages. But, there's some names that are common, and unfortunately for some, so MATLAB is its own thing. And so since MATLAB already had a sum function, when we call this MATLAB package, it just so happens the function is the same name, and so it gets overridden. It's just the fact that the functions have the same name. And if you were to write in MATLAB considers it to be sum of columns when it calls the sum function. So it really just has to do with the fact that this package MATLAB has a function in it by the same name, and it just that function does something different than our original sum function.
Okay. Yep. Okay. That makes sense.
So on the lab, on number 2, you say check that M1 is a matrix.
Yep.
Okay, well, how do I put that in? Do you want it written out as a comment or?
No, so there's a line of code that you run. So remember back when we worked with data frames last week, and we had the as.data.frame would change something to a data frame. We also had the is.data frame that would check to see if it was a data frame. So you can do something very similar with matrices. So since you're not checking to see if it's a data frame, you want to see if it's a matrix, you can use the is.matrix function. And that will return a true or false that tells you whether or not it's a matrix. And that convention with the is and the as, that works for a lot of things. There's also an is dot vector or is dot numeric. I think there's an is dot integer. So you'll find that across different structures and types that you can use that to check to see if it's in a certain format. And then if it's not, you can use the as version of those functions to change them over.
Okay. I was like, because I made the matrix and I can see it, but yeah.
Yeah, so if you ever want to check to see if an object you've created is of a certain type, there's a whole class of is dot functions, and those are what will help you actually check to see if it's the type that you intended.
Dr. Ellis.
Mhm.
So for number 4, where we're creating the 5x5 matrix, it says concatenating 5 vectors. So that means we'll need to create 5 vectors first and then kind of like paste those in.
Exactly.
Okay.
I should add, when you go to do that concatenation, I'm not necessarily saying use that C function. I'm using it more in a way, I'm just saying I want you to figure out how to put those 5 vectors together to create that matrix. And so in the 3.1 script, we had some functions that would help us combine vectors to make matrices.
Would that be like C-bond?
Yeah, exactly. So you want to, yeah, so you've got the C bind and the R bind. So if you want to make those vectors the columns, C bind. If you want to make those vectors the rows, R bind.
Can you just give me a hint for well, number 3 in the lab as far as like where I would put the sequence function if I'm embedding it into the matrix function?
Yeah, so let me put something in the chat. So before, actually, I'm gonna put something in the chat and then I'll talk about it. All right, so I just put a line of code in the chat, and this would create a matrix that had the elements 1, 2, 3, and 4. So notice really what I'm doing is I am embedding that C function inside of the matrix function. So that 1, 2, 3, 4, that vector that I've made there, that's what's going to fill the matrix. So what I'm asking you to do for number 3 is instead of using the 1, 2, 3, 4, the way I've got that written to make the vector that way, I'm asking you instead to use the sequence function. Because notice here, if we wanted to fill a matrix with the numbers 1 through 25, to do it this way, I would have to type out 1 through 25, which would be really long. We'd like a more compact way to do that. So instead, we can embed the sequence function there, which will make a much more concise piece of code to basically produce the numbers 1 through 25. Does that help?
Yeah, that helps. So when you do the vector there, is that replacing the columns? Because you only have in row equals 2 written.
Yeah, so what will happen is for this particular case, since I have in row equal to 2, R is smart enough to say, well, you've got 4 elements, you only want 2 rows, so that means you have to have 2 columns because it's going to fill it that way. Now, for your case, you want it to be a 5 by 5 matrix, right? So you could use the same logic and say, okay, how many rows do you want if you want a 5 by 5 matrix? 5, right? So you could change that to 5, and R will be smart enough to automatically make it 5 columns. Now, for completeness, you could specify both. It would do no harm to say in row equals 5, comma, in col equals 5 as well.
That was my next question. Okay, thank you.
You're welcome. And one thing to keep in mind is if, let's say you give it a number that's not divisible. So for this line of code that I wrote here, let's say I gave it in row equals 3. What will happen is R will go to fill in that matrix and realize it won't have enough elements to fill in a matrix that looks like that. So what it'll do is it will repeat the numbers from the vector. So let me share my screen and show you what I mean by that. All right, so, and sorry, I got all kinds of stuff open here, obviously. Okay, so I just got a blank script open here. So let's say I made a matrix and I fed it 1, 2, 3, and 4, and I told it in row is equal to 10. Okay. Now, obviously, that isn't going to mesh with the values that I gave it. So if we run this, notice here it's going to spit back an error, and it's going to tell me, hey, your data length is not a submultiple, multiple of the number of rows. So I don't really know what to do. So it just kind of guesses. So what it did was it made a matrix that had 10 rows the best that it could by repeating the numbers, but it couldn't repeat all of them. And so obviously it didn't go on to another number of columns. Now, if I specify the number of columns here, let's say 3, it's going to do the same thing. It's going to give me an error and say, hey, I couldn't really do what you wanted me to do, so I just did the best I could. And it just went through and kept on repeating the numbers until it got to the end with 10 rows and 3 columns. So, you know, only specifying the number of rows, I will usually do that if I know that my number of rows is divisible, or the number of elements I have is divisible by the number of rows, because R will be smart enough to fill in the correct number of columns. But you do want to be careful, because you can end up in situations like we have down here below, where R is going to try to fix what you've asked it to do, because what you asked it to do didn't actually make a lot of sense. Now, a shortcut though, I will show you this, is let's say that I wanted to make a matrix of all ones that was a 10 by 10, for example. In this case, I can use the repeat to help me. So notice here, it just repeated the number of ones over and over and over again until I had 10 rows and 10 columns. So you can also use that to your benefit.
Is that a hint for later with the identity matrix?
Yeah, so there is actually, so for this one, my suggestion would be I try Google first. There's actually a
Okay.
function in R that will create identity matrices for you that's easier to use. So that one I would try a Google search, how to make an identity matrix in R, and you'll find there's actually a really nice function that'll do that.
All right, so I'm on number 4 of the lab and I'm completely lost.
Yeah. All right. So this one, so we're gonna make a 5 by 5 matrix with elements 1 through 25 by concatenating 5 vectors. So the first thing you'll want to do is set up those 5 vectors. So if I
Wouldn't that just
know,
be the same-
sorry, say it again.
would that be the same? Oh, wait, no. Okay, you go.
But
Sorry.
we're gonna make 5 different vectors. So if I'm gonna fill my matrix with the numbers 1 through 25, so that's my end goal here. But the first thing I've got to do is make 5 vectors. What numbers should be, let's say, in the first vector?
1 through 5?
Yeah. What number is going to be in the second vector?
6 through 10.
Perfect. So the first thing we want to do is make those vectors. So if we share my screen.
So would that be like what we did for number 3 in module 3.2?
Not close, but not quite. So for this one's actually going to be closer to your 3.2 script, or probably 3.1 script. So in the 3.1 script, remember that we made something that looked like this, creating a matrix from vectors. You're going to do something really similar to this, except instead of, here we just put together 2 pieces. You've got 5 pieces you're going to need to create. So to help get you started, what I would do is first thing you want to make those 5 vectors, right? So I would maybe call them V1 through V5.
Okay.
And the next thing is you got to figure out, well, what numbers am I going to put in each of these, right? So the first one you already told me would be 1 through 5, right? So
Do I want like a code that's like M3 equals like n row 5 n call 5?
No, so this one, we go back to our 3.1 script, you're going to want something more like this. So you're going to create your 5 vectors first, and then notice to put these together, we use this R bind and this C bind. You'll want to use something like this to put them together.
So what's the difference between, row and column bind?
Yep.
Okay. So would I want to put both of those functions into M3 so that it combines everything?
You're only going to use one of them. So as a first step,
yeah. Okay, sorry.
No, you're good. First step, make your 5 vectors. So start there first. And that's one of the hardest parts about coding is learning to compartmentalize the pieces, because we always want to jump to that end result. And so forcing ourselves, to break it into bite-sized pieces it's definitely a skill that you learn as you go along, especially when we get to bigger tasks. It can be really difficult.
Okay.
All right, so you got your 5 vectors, right?
Yes, ma'am.
So if we had, let me share my screen again here. Actually, hold on, give me just a second, I need to check something. Okay. So you made, all right, so your goal is you've made these 5 vectors, and you want to put these vectors together in such a way that they look like M2, which you made in the previous step, right? So I don't have M2 made on my screen, but you tell me. So when you call M2 and you look at it, how do the numbers fill the matrix? Do they go down the columns or down the rows?
Down the columns.
Okay, so if I wanted to combine these 5 vectors together to make the same matrix, would I want each vector to be a column or each vector to be a row?
A column.
Column. So you're going to use C bind or R bind to put them together.
And so, okay, M3.
Does that help?
Yep. So it'd be M3 equals C bind, and then put all the vectors in.
Exactly. Exactly. Because what that's doing is that's basically going to put them all side by side and make you a matrix that combines those vectors all together.
Okay.
Oh, I wanted to remind everyone, as you all are working on other classes or research projects, if you come across things that you're going to need to know how to do in R for, those practical other things that you're doing, feel free to send me an email and I'll make sure that I get that either somewhere in the curriculum for the course so we make sure that everybody learns it, or if it's something a little bit more specialized, I can help you individually do that for whatever you need. Because I imagine a lot of people need to learn R for practical purposes. So I want to make sure that by the end of the semester, the things that you need to learn how to do for whatever it is you're doing, we make sure we cover that.
All right, so I'm coming up with an error that says number of rows of result is not a multiple of vector length.
Yeah, do you mind to share it for me? And
I'm the weird one with the desktop. So
oh yeah. So on yours, which step is this still on? Is this on step 4 still?
say that again.
Which step are you on?
4, yeah.
So on 4, oh, that means that one of your 5 vectors is not the same length as the other ones. So what I would do is I would call each of those 5 vectors and double check them.
Yep. Okay. Thank you.
You're welcome.
Wait, actually, no, we'll just go on to the next one. So then for 5, it would be identical and then M2, M3.
Yes.
Okay.
But well, oh, you could use that one. So here I actually wanted you to use one of the logical arguments though. So the logical arguments are the ones that are like less than, equal to, not equal to, those types of things.
Gotcha.
But be careful, as a warning, make sure not to use a single equal sign. Because remember, a single equal sign is assignment. It's not a logical operation.
Mhm. So then it would be M2 equal M3.
Exactly. And if they are all the elements are equal, because it's going to check the elements one by one, you'll see all trues.
Nice. Okay.
This doesn't really apply to the matrices, but just as another like logical argument R question, like let's say I wanted to use less than or greater than, I would just do the first equals and then the greater than.
It's usually, I think it's the, I always have to check this, but I think it's the other way. It's the less than and then the equal, or the greater than and then the equal.
Got it. Thank
Let
you.
me double check that, but I think that's, there's some syntax things I always have to double check myself on. And that is one of them. Yes, it's less than and then equal. The other thing I'll warn you about, I didn't have it in here, are when it comes to doing ands, ors are pretty straightforward because they're just going to be the single up and down bar. Ands can get a little particular whether you use one or two ands. And I'll be completely honest with you all, when I need those, I'll usually try a single, and if it doesn't work, I put in a double and it works just fine. That's usually my troubleshooting.
Like when you want to say and, you just do the and symbol twice.
Yep. Well, it's either once or twice. So for some instances, you use a single one. For other ones, you use a double. It depends on what you're trying to do. So I just by default always try the single one first. And if it didn't do what I want to, then I put in a double, if that makes sense.
Yeah.
There is a technical reason of when you use one which, I just never remember. And so that's usually how I troubleshoot it.
For questions 6 and 7 about using the apply function, about getting the row and column sums, is that second number in that sequence when you're like apply M3, 1 or 2 sum?
Yep. That's
So
exactly.
one is the row sum, correct?
Hold on, that's one of those ones I always have to double check. I think that's right. I think 1 is row and 2 is column.
Okay, that was, yeah, that, I just wanted to double check that.
Yep, 1's row, 2's column. Yep,
Okay,
and that's
thank
how
you.
you toggle between those.
Yes, and I had like is there a reason for it being like 1 and 2? I was just like working. No.
No, just whoever wrote that apply function, that's how they made the arguments, was the 1 and 2. I don't know if there's a particular reason why they chose 1 for row, 2 for columns. It could be that when we think of, like when you go to call a matrix, the first number before the comma is the row numbers. The one after the comma is the columns. So that may have been based on how indices are typically done for matrices. That's probably why they chose 1 and 2 for row column. But that's just how whoever wrote that function, that's how they set up the arguments.
Okay.
The same in Python, and I'm pretty sure that's the reason.
Yeah, it's a really handy function. You know, I always debate on when to show students the apply function, because so you can do the same thing with loops. And it's funny, whenever I talk to people, whichever one you learn first tends to be the one that people think are the easiest. So I always debate, should we do loops first or apply statements first? And since most of you are going to be primarily working with data, I think the apply statement's probably more appropriate. Sarah, I haven't heard from you, and I didn't get to see your puppy last time. I was a little upset. How's he doing?
He's doing really good. He's sleeping right now. The ice storm, he's not really happy about with it.
Yeah, mine isn't either.
I got up at like 7:30 this morning to take him out, and touching the ice on his feet with the grass, he was not happy about that. So much so that
Same way.
he ended up taking a poop on the sidewalk. So I felt very like, oh no, like I was just panicking. But he's now gone back to sleep because he's lazy. So
I like to think when they're just happy. You know, a good dog is a happy, lazy dog.
right. No, he's doing all right. He doesn't know what to, because he's only 7 months old, so he's kind of like learning the world as we're living in it right now. So he's like, what is this? Why does this happen? So, but he was definitely like a deer on ice this morning, so he was all over the place. So
I love Dobos around that age because I don't think they've grown into their legs yet. So they're just like uncoordinated, just floppy, just everywhere. And it's so cute.
he's really good. He's very entertaining, that is for sure. But I guess I'll have to send you weekly auto pics now to
I mean, I'm not saying that I'm requiring them, but I would appreciate them.
I have plenty, so I can send them to you. No problem at all.
I pretty much love all cute animal photos, just so everybody knows.
Mm.
So for number 10, when it says change the element M3 to be equal to 10, do you want all of the numbers to be equal to 10? I think you're muted.
Sorry about that.
Oh, good.
There might be a problem with the PDF. Let me look at the one on Canvas. So the version I'm looking at says change the element M355 to be equal to 100.
Oh, that was probably just me that messed up.
And it might be, did you, are you on a Mac?
I'm on the desktop.
Oh, gotcha. I was gonna say, sometimes when you open up a PDF, although most of the time PDF, anyhow, but yeah, it should say M355 to be equal to 100 is what it should say.
Okay. But, oh, okay, so that's when all the elements are added together, they equal 100.
Oh, sorry. No. So what I'm saying is, so you've got M3, which you created in that previous step. So after that, it's got the square brackets 5, 5. So what that's doing is that's going to call the element that's in the 5th row and the 5th column. So you're just going to set that single element equal to 100. So basically, the bottom right-hand corner, the one that was previously 25 will change over to 100.
Okay, sounds good.
I actually had a quick question on number 9. I guess it's the same as the other logical argument. Do you just want like the equal sign, and then if it has all true?
Yep, that's exactly what it's for.
Perfect. I just wanted to make sure I did that right.
Yeah, I tried to put a couple of those in there with the equal sign because I think that's I know when I was first learning, that was a common mistake that I would make, is I would always forget that the logical for equals was 2 equal signs, not 1. And so it would always catch me.
Luckily, I have used Stata a lot, so it's the same in that.
So you're used to that one. Yeah, it would, like I said, it would always catch me when I was first learning. I haven't used Stata before. Is Stata mainly, do you write code for Stata, or is it mainly have buttons that you push?
Kind of more buttons. You can do a little bit of code in it, but it's more buttons.
Gotcha.
What's really nice about Stata too is that you can essentially take the buttons and it will come out as code as well. So if you wanted to write it by hand, but you wanted to, for example, we had to do a Poisson regression. I didn't know how to write that, but if you went to epidemiology, Poisson, it would write out the entire code of the variables that you had. And then you could copy and save it for future code references, or if you wanted to practice at your hand edit as well. Super nice, super cool.
I need to download it and just play around with it. I've never had the need to use it, but it would, SPS is the same way for me. So both of those I need to download and just play around with, because I know a lot of people do use those. So it'd be beneficial to have some, at least some frame of reference when people talk about them.
One problem with Stata is it's expensive.
Agreed.
Yeah, that's one of the real benefits to R, is where it's free.
Mm-hmm.
The school does have Stata on the virtual machine, but it's super slow. But it's there.
Okay, I have a question on the last couple questions here. What do you mean by change the element M355 to be equal to 100?
Yeah, so M3, that's that matrix you just created, which was a 5 by 5 matrix. So anytime after a matrix you put those square brackets, what that allows you to do is to call the individual elements of the matrix. So by having the square bracket 5, 5, what that's saying is you're going to call the element in the 5th row in the 5th column. So right now in M3, that element is equal to 25, but you're going to change that element to be equal to 100. Does that make sense?
Yeah, but how? Like, do I change that number?
Yeah, so so all you'll have to do is you'll put M3 square bracket 5, 5 inside, and then just put equals 100, and it will override that 25 and make it 100. So by calling that individual element but putting an assignment operator with it, you can change individual elements of the matrix. So after you do that, call M3 and you'll see that that 25 has been changed to a 100.
I didn't get an error, but I can't find where I can see it.
Do you want to share your screen?
Okay.
Yeah, so one way to see it is just right below that in your script.
It doesn't say error, so I'm just assuming it went through.
It did. So if you go up to your script where you wrote that line of code, just click enter. Now M3 is an object that you've created. So you can just type M3 and then just run that and it will call that object into the console.
There we go.
And so now you can see your 25 has been changed to 100.
Okay. Okay, cool.
And then for number 11, that's the one where you'll go to Google and Google how to make an identity matrix. One of the, I'll tell you, there's a function that will do it for you that is super quick to use, is one of the options.
Okay, I'm gonna stop sharing now. But we're just making new matrices. Is that what you want?
So you'll call one of them I1 and the other one I2.
Okay. Thanks.
You're welcome.
Can you lay down, Pop Pop?
Has anyone gotten to the point yet where they copied the code over from the PDF? Is anyone getting encoding issues?
I copied it over, but I haven't seen any issues. So
Yeah, it doesn't happen all the time. And usually with code, it's okay. With comments is where it can have problems, especially if you've got a word that I think has two F's or an F and an I together. It'll happen sometimes.
On number 11, I found the function to do it the easy way. Is there another way that's easier than just like making a vector with all those numbers in it?
I wish there was, but no, the second way will be one of the more labor intensive ways. That basically like what you did earlier with the other matrices.
Yeah.
You could either define one large vector. How do you do a 5 by 5 identity? Yeah. So you could either do one large vector, or you could create 5 separate vectors like you did, what was it, with M3? Yeah, with M3, and then, combine them together. But yeah, there's really only one easy function to do it, and then the other ones are going to be a little more intensive. You could write, for those of you that have worked in coding before, the other way to do it that's a little bit quicker would be to do a loop, but I haven't shown you all loops yet. So you could make a matrix of all zeros and loop through the diagonal and change those to 1. But again, I haven't shown you all how to do that.
Yeah. Thank you.
Okay, so going off of that, so for I1, I did I1 equals diag 5. Do you want us to put other numbers in there, or is that it? Like that's
it. So
okay.
now call I1 and see what it looks like, and you'll see it's an identity matrix. So that's the easy way. And so part of the purpose of this to see is, so in R, you are always going to find multiple ways to do stuff. Some ways are going to be more labor intensive than others. At the end, you're going to get the same answer. So, sometimes it's just a matter of, can we get things to work? And then sometimes it's a matter of, can we be more efficient? So creating these identity matrices is a good example of that, because you find that one function, the diag function, which makes it like that. Or another way to do it would be a more labor intensive way, like you did up in step 4 when you created that 5 by 5 matrix.
So the second way would be like step 4, where you want us to combine all of the.
Exactly.
Okay.
That's one potential. There's other ways to do it too.
I did, for the second one, I did diag n row equals 5, n col equals 5.
Oh, so that n row, so those are for the diag one. So you're really doing it the same way. That n col and that n row are getting ignored in your second function is what's happening.
Okay, I'll try to figure out the second way.
Yeah, so let me share screen and I'll help you with the second one. So similar how you did this in step 4, where we specified the 5 vectors. Notice you could do the same thing again. But since we're going to make it an identity matrix, so one way to do it would be to look at the output from that diag function that you use to see what the identity matrix looks like. And notice that the first column looks like this.
Mm-hmm.
So then for the second vector, where would I need to change the 1's position to?
It would be the second.
Exactly.
Okay. Okay.
And then, so you go through, manually create your 5 vectors and then put them together just like you did with the M3 matrix from step 4.
Okay. Thank you for always being so helpful and dealing with my questions.
Oh, no, that's one of the reasons I set class up this way, because that's the hardest part about coding is you all are going to get stuck. And if you're by yourself, it's super frustrating because you're going to bang your head against the wall. Whereas here, and as class progresses, my hope is that everybody gets more comfortable with R. Hopefully we're going to transition to where you all are going to be able to help troubleshoot each other as well. Because being able to troubleshoot other people's code is going to make you even better at troubleshooting your own code, if that makes sense. Because there's nothing more frustrating, and this has happened to me, I don't know how many times, if you're looking at your own code and you just cannot see what is wrong to save your life. And then somebody just looks over your shoulder and they're like, oh yeah, you forgot that comma. But that's how it works, because you've got tunnel vision because you're looking at it so closely. But getting other people to look at it really helps.
I feel like for the most part, for the homeworks, I've been able to figure it out myself, and then I get to the lab and I'm like, okay, like what's going on?
The lab's the harder step. So it's intentionally built that way. To the lab, it's meant to be that next step up from the homeworks.
Okay.
How do I get to output the results on 12? Because I multiplied, I got like what I was expecting to get. I used the print command, but
So by output, I don't mean it to output in your script, just down in the console
okay.
down below. Yeah. So you don't even have to use the print statement. You can just do the multiplication between the two matrices. And as long as that, pops out in the console down at the bottom, then you've done exactly what you need to do.
Okay, cool.
And just like last week, I will probably get the next one posted tomorrow. Brooke, did that give you enough time? Okay, perfect.
Yeah, I did most of both early. Yeah, I did both of the homeworks and then this weekend, but I got stuck on like one part of the homework, which was the question I asked you as soon as I got here. So yes, it was very helpful. Thank you.
Perfect, good. Yeah, I will try to get those. I've got next week's ready to go. I just need to always double check it. But like I said, I should have that posted tomorrow.
So do you want the bottom part at the below the top part in our script, or are you okay? Like, how do you want that?
You can just copy and paste it right below. After you get done with the, the 1 through 12, just copy and paste it right below the 1 through 12. And then the only thing you'll have to do for that code is I've got those comments that say like chunk 1, chunk 2, next to the colon there. That's where you'll write your comments that say what each of the chunks are doing.
Okay. And so if I copy paste like I copy and paste 1 through 12 into our script, do you still want comments?
Yeah, no, as long as you made the 1 through 12 the comments, that's perfectly fine. If you copy and pasted that 1 through 12, you might end up with that encoding issue that I was talking about.
Oh, I do, but I fix it and then because it all comes in one line, so it gets an issue with that way. So yeah.
Yeah, no, that's perfect for the comments. I just don't want to see any basically naked lines of code. Like I always want to comment with them so we know what that line of code's trying to accomplish. So if you've got the 1 through 12, I mean, that does that.
Okay. Why will you not? Okay. It's just easier than flipping back and forth.
Oh, no, that makes perfect sense to me.
On number 12, you say multiply M3 and I1 and output the result. Does that just mean click run?
Yeah. So I just want, so there's two different ways you could do it. If you just do the multiplication and you run it, it will pop down to the console, which is perfect. That's what you want to do. Or you could assign that multiplication to be equal to an object. If you do that, then you have to call the name of the object below it, if that makes sense. So here, let me share my screen. So
do you care what the object is called?
No, you could do it either way is what I'm saying. So either way would be perfectly fine. Let me.
Okay, because I just did the M3 times I.
Yeah, no, that's perfectly fine. So what I mean by that, so if I come down here, I could do, for example, 1 plus 2, and I can run it, and down here I get the answer. Or I could, I don't know, create an object named example and run this, but notice I don't get the sum down here. If I name it an object, I have to call the name of the object to get the sum.
Okay.
Either way is fine. You could have just done the multiplication, or you could have signed the multiplication to be equal to an object. But if you do that, then you need to call the object afterwards to get it to output down here.
Okay.
Do you all feel like it's getting a little bit easier to look at the R Studio? Does it seem a little more like your eyes starting to adjust now? It doesn't seem as, awkward seeing all the windows, or is it still pretty foreign?
I feel good about it.
Feeling better?
I feel getting better, and the code is definitely coming easier.
Good, good. I'm glad to hear.
For the rock, paper, scissors part,
Mhm.
when I run the for loops to actually play the games, I guess that's just
Is it giving you an error?
I keep getting pluses. The output. So am I just like missing, am I missing like a bracket or like an indentation or something?
Yeah, you actually have to run that entire chunk together. So yeah, so you have to start all the way so that bottom bracket on line 131.
Yeah.
Unless I missed a bracket in there, which is possible. Run all of that and see what it does. Oh, actually, sorry. What? Go down to your console and click in there. We actually need to cancel that. Click enter, or actually do escape. Sorry, not enter. There we go. Okay, now run the top one. I think you had a partial in there from before, and so it kept on waiting. So now it ran. So what had happened is you had ran something that was partial earlier, and so it kept on waiting for you to finish that one when you were rerunning it.
Okay.
So that's why it just needed like a clean reset, if that makes sense.
Gotcha. Thank you.
You're welcome.
So when we run the game, what are we supposed to see?
Yeah, so the way that I've got the code written, you won't necessarily see anything in the console at first. And the reason for that is because most of the things I've assigned to be objects. So for example, when we look at chunk one, the only thing that's going to happen when you run that line of code in chunk one is in your global environment, you'll get a new object called in.games. Now, if you want to see that in the console, you could call in.games below it.
Okay.
So you can do that to see what the different pieces of output look like. But more what I want you to do is read the code, think through. I should have asked this. Has everybody played rock, paper, scissors before? Has anybody not played rock, paper, scissors? All right. So what you want to do is more as you read the code, think about how a game of rock, paper, scissors works, and then how that would relate to the code that's written, if that makes sense. So if we think of the different pieces of the game, how are these lines of code replicating how that would work in the real life? So for example, if you look at chunk 2, notice I'm creating a vector. It's a character vector. And the elements of that vector I'm assigning to be rock, paper, and scissors. So in terms of the game rock, paper, scissors, what are those 3 things? Does that kind of make sense?
Yes. Sorry.
Oh no, you're good.
Is chunk number 2 a character string?
Close. It is a vector with 3 character strings in it. So each of those different choices. So rock is a character string, paper is a character string, and scissors is as well. So as a hint, when you get to chunk 3, again, you want to think about what this is replicating in a real game of rock, paper, scissors. Have you ever played rock, paper, scissors against somebody and they always choose the same outcome? Like, if you ever play anybody and they like always choose paper? Think kind of about that when you're looking at chunk 3.
My computer is getting really mad at chunk 6.
Might be, do you want to share your screen? So you have to run
Yes.
all of chunk 6 at the same time. So if you miss
Yes.
any of the brackets, it'll get angry.
Give me a second. Let's try again. We do the whole chunk.
I think you missed some of chunk 6 when you were copying. Oh, it's because, so when you copied yours over, so have a look at the PDF. Do you see how all of the if statements are on different lines?
Yeah. Oh,
I
that's
think
it.
the problem is when you copy paste it over, yeah, it puts some of them on the same line. Try it now.
Yep.
Yeah, it sometimes R doesn't care about the lines, but when it comes to if, and we'll learn about if else statements and else statements later, those you can get kind of finicky with, being on the right line.
Thank you.
You're welcome.
I have a similar issue, but it's not quite the same.
Yeah, do you want to share your screen? We'll take a look.
I mean, something's not right in the way I broke it down. I don't know what it is.
Oh, it's in that first line that starts with 4. I think it's a spacing issue. So there's between the I and the N, there should be a space, and between the, sorry, it should say for I in, so I space the word in, yeah, there you go. And then a space after the word in and the 1. Yeah, try that now and see if that fixes it.
Okay, the little X went away. Maybe it'll work. Okay, that works. Thanks.
And just as a reminder, once you get through lab and you're done, then you are finished with this week's work and you can enjoy the rest of your week. I don't want anybody to feel like they have to stay, once you get finished. See you next week, Daniel.
So chunk 6 is just showing 6 different ways that the game could be played out.
Exactly. So if we think about it, so you've got the 3 options. So the options are, if you and I were playing, we could tie, which we would have the same thing. But then we also have to account for, like, if I have rock and you have paper.
Okay.
Or all the different ways to specify who wins based on those potential pairings.
Okay.
you may have already answered this, but is chunk 4 is actually running a simulation?
Cameron, you're breaking up. Sorry, I only caught like every other word there.
Can you hear me now?
I can. Your video's frozen, but I can hear you.
Let me- Just
Yeah, you're still breaking up. Maybe try typing it in the chat. See you next week, Shelly. Cameron, I think you might be back now. Your video's unfrozen. Ah, okay. So chunk. Yes. Yes. So it's really chunks 4 through chunk 6 are running the simulation. Chunk 4 is running the piece that actually pulls what people choose. Chunk 6 is making the comparison. Because, really, if we think about playing the game, there's 2 steps to it. There's the choice that each person makes, and then there's the comparison between choices.
But chunk 4 is like that simulation that's creating the vector of choices based on the probabilities that we already assigned.
That's exactly right. See you later on.
All right, I'm also leaving. Have a good week.
Have a good weekend.
I had a question about chunk 5.
Yeah.
So I'm not I tried to look it up, but I'm still not 100% sure what that rep function is doing.
Yeah.
So
what the rep does is it stands for replicate. So when you look at the function, whatever the first argument you have, that's what it's going to replicate over and over again. So in this line, our first element we have is NA. So essentially what this rep function is doing is it's going to create an empty vector that has length equal to n dot games. What it's doing is it's creating a vector that we can store the winner in for each of the games. So that's why it's blank to start out with. Since R is object oriented, you have to pre-specify an object before you can fill it. So we know if we're playing 100 games, we're going to have, for each of those 100 games, somebody is going to win the game or it's going to be a tie. So this is just creating a vector that we can store the winners in. And so chunk 6 is actually going to assign the winner for each of the games, and it's going to store it in that winner vector.
okay. Yeah, I mean, I kind of figured that it was creating a placeholder. I guess my question, maybe to reword it a little bit, is why couldn't we just create an empty vector of length 100 instead of you?
That's what this is doing.
Oh, so you have to use the rep? You couldn't just do winner equals, I don't know. I guess there's not a way to pass empty values using that C function.
There is, but you'd have to type, if you use the C function, you'd have to type NA 100 times.
Oh, okay.
Oh, okay.
I see.
Pieces in it. Yeah.
Okay, thank you.
You're welcome. Jacob, to that point, you could have done that, but what happens is it's a memory issue. For this, it wouldn't have really mattered. But what would happen is it would just keep on, and I think that would work, it would just keep on appending on the new pieces to that vector. But by pre-specifying it as length 100, you're pre-allocating your memory, which I mean, I realize that's more of like a computer science thing than what we're doing here. But typically that's how you want to predefine your vectors if you're going to fill them, if that makes sense.
Gotcha. So it's like dynamic.
Yeah.
Okay. Thank you.
You're welcome.
Okay, I think I'm done. Thanks, guys. Have a good weekend.
You too. Have a good weekend.
Bye.
Christine, Lindley, I haven't heard from you all today. How's it going?
It's been okay. I'm still working on question 9 of lab 3.
Yeah. So for this one is going to be very similar to what you do in number 5. So for number 5, what logical argument did you use?
I haven't picked one yet.
Sorry, I couldn't hear. Say it again.
I haven't picked one yet.
Oh, okay. So for the logical arguments, if you want to see if two things are equal to one another, you can use the equal sign, but we have to be careful because in R, you can't use a single equal sign as a logical piece because a single equal sign is an assignment. So instead, we can use two equal signs.
That's cool.
So let me share my screen here. So just as an example, let's say that I set A equal to 1, B equal to 2, and C equal to 1. And let me run these. If I wanted to see if A and B were equal to one another, I could do A equal B. And run this. And notice it'll tell me false because they're not equal to one another.
Yeah.
Or I could do A equals C. So you want to do the same thing, but you want to do this for those matrices.
I see. It worked. Thank you.
You're welcome.
Okay, I'm gonna head out. I hope you guys have a good week.
Have a great weekend. Christine, how's it going?
Okay, bye. Thank you.
See you, Cameron. Have a great day. Christine, I know you're having internet issues. If what I typed in the chat doesn't help and you can see my screen, let me know in the chat and I can bring up our studio to show you what I'm talking about.
Okay, now that more people are gone,
Is it
the
doing better
Wi-Fi
now?
is getting faster. So I'm not going to turn on my screen just because that might slow it down again. I'm not sure, but we can definitely try. So I currently have, I switched it to this, which I don't think, I think this just means I don't understand.
Yeah, so you're, okay, so let me share my, you can see my screen, right?
Yeah,
Okay.
yeah.
Let me pull up our studio and talk about the difference here. Oh, stop share, stop share. Not what I wanted there.
Because I ran max V2 by, which V2 by itself just to look at it, and I came out with like 99. I was like, what is this function?
No. So that's actually what you want to do. So
Okay.
be careful here because there's a I'm not asking you to reassign the max value.
Okay.
You're looking for the index that has the max value. So I think I've already got these ran in my computer. Let's just look at V2 to start with. Okay. So this is what V2 looks like, right?
Yes, and that's what I have.
Okay. So what is the max value equal to in V2?
The max value is equal to 50.
Right. It's this element right here.
Yes.
The which function doesn't tell you the value of the max. It tells you which of the elements is equal to the max. So for example, notice here.
Oh,
you see what I'm saying? So element 1 is equal to 1, but element 2 is equal to 1.5.
Right.
So which element is equal to 50?
So that's 99. Now element 99 is assigned to 50.
Exactly. So what we want here is we're asking which element of V2 is equal to the max of V2.
Oh, sure.
Does that make more sense now?
Yes.
So that's why when we run this, we get 99 because 50 is the 99th element.
Ah. Wow.
That's one of the really confusing things about the which function is because it's not going to give you the value, it's going to give you the index. But learning how to use the which function is really important because, so for example, if you were working with a data set and you wanted to, let's say you had this huge data set and you wanted to pull out, let's say, all of the observations that had high blood pressure, for example.
Right.
You can use this which function to find all the indices of people who had high blood pressure and pull them out.
Right. Right. Okay. That makes a lot more sense.
Yeah, but the first time you use this, it always gets confusing for people because, again, it's not the value, but the index.
It's the element. Yeah, the index. Okay. Thank you so much.
You're welcome.
So originally I got the right answer, 99. And I was like, what the heck? This is not right. All right.
I'm going to run and get some more coffee. I'll be right back.
Dr. Elise?
Yeah.
I got a question regarding number 11 or 10 actually.
Yeah.
Do you mind me sharing my screen?
Oh, please do.
So element 5 of matrix 3. I guess I didn't do it right because all of the data has been changed to 100.
Yeah, so you recreated the whole matrix here. So what I'd like you to do is actually delete out that line of code and then go back up. I think it was step 4 where you created M3 and recreate it. Yeah, there you go. And actually, let's go back up to your number 4 because number 4, we need to change number 4 as well. So notice that number 4 says create a 5 by 5 matrix M3 with elements 1 through 25 by concatenating 5 vectors together. So you have to start by creating 5 vectors that you're going to put together. So notice here you haven't created any vectors first. So before you even do the matrix step at all, you need to make 5 different vectors. So let me, do you mind to stop sharing your screen for just a second?
Sure.
So I'm going to go back over to my RStudio. So if you go back to the module 3.1 script, have a look at this section right here. Create a matrix from vectors. So notice in this example, we created 2 rows.
Yeah.
And then we put them together to make a matrix. So you're going to want to do something similar, but you're going to make 5 rows or columns, depending on how you need to put it together. And then you're going to combine those. So you'll have 5 different vectors, and then you're going to either want to use the R bind or the C bind to put them together.
See. So this question 4 doesn't matter because you didn't say.
Do you see what I'm saying? How question 4 says to make the 5 vectors first? Yeah, so it's just a different way. Now the way that you made it makes the matrix, but I wanted you all to practice making the vectors and putting the vectors together to make a matrix.
I see. I got it. Thanks.
You're welcome. Christine, were you able to get through the 3.2?
Yes.
Okay.
And I turned it in and the confetti was fire.
Awesome. I know I need to go in and pretend to be a student and submit stuff to see if it does that for me. I'm really curious about this.
It's really fun. It really feeds it's really positive and reinforcement.
There's have you all ever heard of squashing tomatoes? Do you know what that is?
Yes.
I would say there are websites that do similar things that you can click, after you work for 15 minutes, that'll do the same thing just to get that positive reinforcement. And there's also listing websites where you can make online lists that do the same thing. Every time you check one thing off your list, it gives you some kind of positive reinforcement, like fireworks or however that website's set up.
For some reason, I'm really motivated by that. I don't know why.
No, I think there's studies that have shown most people are. I am definitely a lister, and I need to be able, I don't do well with the digital ones, but I need to be able to highlight the things that I do off, and it's the same type of thing. I need that positive, pat on my back, if that makes sense.
Yeah, I have my whiteboard and I scratch off my whiteboard assignments for that week, and then I have my planner, which I do the same thing.
Yeah, it's just there's something about that I'm okay, I feel like I'm doing stuff.
Yeah.
And sometimes if I need to pick me up, I just put a couple easy things on there just so I can mark them off.
Yeah, like make bed.
Yeah,
Like
exactly.
something for daily list. I have like a daily list, a weekly list, and then month list. For my daily list, make bed is on there because I feel accomplished.
Yeah, no, it's just, a couple like 5-10 minute tasks just to make me feel like I did something.
Yeah.
Lindley, were you able to make those vectors and put them together? Did that make sense?
Yes, I did.
And then now that you've got that, do you want to look at number 10 together?
Sure.
Okay, I'm going to share my screen. All right, so here's my RStudio. So let's talk about what that notation does. So remember that, let's say I'm going to make a matrix and I'm just going to call this one A. And I'm just going to give it the numbers 1, 2, 3, and 4. Okay, so I've made a matrix and I've named it A. And so let's start by looking at what A looks like. So here's matrix A. Remember that whenever we call a matrix, if we put the square brackets after it, that allows us to call elements from the matrix. So for example, if I put 1, 1, and I run this, notice that's this element, so it should return the number 1. If I put 1, 2, that should return this element. And it does. So for number 10, you've got a matrix and you've named it M3. And notice that I've got the square brackets 5, 5. That calls a single element from M3. So when you first made M3, can you tell me what is this element equal to? When you first created M3, what's in the 5, 5 slot?
It's 25.
Exactly. So what that question is asking you to do is it's asking you to change that 25 to a 100. So before you do that, let's go back up to my A matrix. Let's say for my A matrix, I wanted to change the element that's currently a 3 to a 50. What I can do is I can call that element and I can set it equal to 50. Run this. And now let's look and see what happened to A. Notice that A now has a 50 in that position. So does that help with what you want to do with number 10?
Yes, it really helps. I still got a question regarding 11. So matrix I1 and I2, what is I1 and I2, like column or row?
So those are both going to be identity matrices.
Okay.
So here you're going to want to use Google to help you. So what I'm just saying is name the first identity matrix equal to I1, just like you named the matrices up above M2 and M3, you're just going to name these I1 and I2. So here's where you'll want to go to Google and see if there's an easier way to make an identity matrix. So what you're going to find, hopefully, is you're going to find a function that'll help you. And so you'll see what the identity matrix looks like. And then you'll have to use one of the methods you used up above to create the second one. But you're going to end up with I1 and I2 being the same thing. You're just going to create it 2 different ways.
Cool, I get it. Dr. Elise,
Yeah.
I got a question regarding 12.
Mhm.
I cannot multiply these two together. I have no idea why.
Yeah, so do you want to pull up your screen? Are you using, so just as a reminder with matrices, okay, that looks right. All right, do me a favor. Let's look at what your M3 and your I1 look like. Okay, so I think I see what the issue is. So M3 looks good, but now let's look at I1. So to do it, instead of clicking on it there, let's type I1, highlight it, and run the object. Yeah.
Sorry.
No, you're good. Okay, so see, I1 is only equal to the number 5. So let's go up to where you assigned I1. So
I have 2.
Yeah, so your second way is not correct. So you don't want to define I1 and I2 twice. You want to create I1, which is an identity matrix of dimension 5, one way, and I2 a different way. So notice up above, you've got I1 and I2, you're making them the same way. Yes. Okay. So that second way, that's not correct. That doesn't make an identity matrix. So what you want to do for I2 is use one of the ways that we've already used in class. So for example, if you want to stop sharing, I'll share my screen. So remember that one of the ways that you made a matrix before was you specified 5 different vectors and then you put those vectors together.
Mm-hmm.
Well, that's one way you can make an identity matrix. So notice here, ignore this other code, just look at this piece right here.
Right.
We can start by specifying 5 vectors. So notice the first one could be the first column of the identity matrix. The second one could be the second column, and so on. And then we could put these together to make an identity matrix. So notice, I1 and I2 will end up being the same matrix, but you're constructing them using 2 different methods.
I see.
But after you fix that and you fix that I1, your multiplication should work there.
Cool. Thank you.
You're welcome.
So in dot 2 in module 3, section 2, I created the my full name, screen time, matrix. I created all of that. And then the instructions says create a list, name, list underscore example that contains the 3 elements created in step 1. So do you want me to make a matrix with Christine Lynn Vasquez, and then that I embarrassingly have probably like 69 hours of screen time? Or oh, you're muted.
I think all of us have an embarrassing amount of screen time these days. No, so I don't want you to make a matrix. I want you to make a list.
Okay, so just list them.
Yeah, so you're going to take those 3 individual pieces and put them together in a list. So it's going to be similar to
like when we did like over the rainbow.
Well, not over the rainbow, because that one wasn't making a list. That one was making a vector. This is going to be more like, give me just a second. Let me find it in the module 2 script, and then I'll pull it up so you can see it. All right. So
a piece of cake to find 4 characters.
Okay. So at the very beginning of the module 2 or 3.2 script, so we've got this list section. So notice what I've done here is I'm using the list function to make a list. And then inside of it, I'm giving it 3 different pieces. Okay.
Okay.
So what you're doing is something very similar, except first you're going to build these 3 pieces and then you're going to put them inside of this call. Does that make sense?
Yes. So doing a matrix, would like where siblings equals 1 is, would I put would would I put the name of my matrix that I gave it?
Yeah, so I'm going to show you my key so you can see what I mean here. So here is the full piece here. So you don't want to make the matrix inside of the list call. So those first three things that you need to make, you want to make them separate. So notice here, I've got the vector with my name. I've got the vector with screen time, and then I make the matrix.
Oh, you split up all 7. Like, oh, you spent 10 on one day, 10 on another day. Okay.
Yeah, because that's the length 7. That's why we need a vector with 7 elements in it.
Yeah, I'm gonna go back and do that.
But then to put them together, notice what I do. So I make all 3 separate, and then here inside of the list call, just like we did in the 3.2 script, the first thing is, and you could use whatever names you want here, but I've got the object name is equal to the full name that I made up here. Time is equal to screen time that I made here. And matrix is equal to the matrix that I made up here.
Okay.
You see what I'm saying? So you make them outside of a list call and then put them inside.
And put them in. Yes, I understand that. That makes a lot of sense.
Now you could, now in the 3.2, we put them inside, but for more complicated things like matrices, it's easier to make them outside and then put them in.
And then put them in. Okay.
Now you could, just for completeness here, you could do this. If you didn't want to make them outside, it's just, you'll see how much longer the line of code is.
Yeah.
Notice everywhere, so like instead of full name here, I could put this and just replace them.
Yeah, but that, I understand how that may not be as easy for someone looking into your code to easily pick up on.
Exactly. That's exactly the reason there. Because these are gonna, they're gonna do the exact same thing. Oh, I messed those up where I copy and pasted, but you get the idea.
I know what you mean. Yes. You would have like basically 2 lines of code, except so someone would have to really break down what you're doing.
So for readability, that's why it's easier to make them outside and then put them in.
Yes, I can see that.
And as far as time, it takes the exact same time to run. There's really no benefit to just putting them directly in.
Yeah, other than readability.
Right. Lindley, do you mind to bring up your screen? I just realized something. I'd like to see your step 3 for the lab.
Sure. This one?
Okay, oh, never mind. It looks good.
Okay.
For some reason, I was thinking when I looked at before, you didn't use the sequence function, but that looks good.
Okay.
All right, so I'm gonna try to start my video now that my roommate's not on the Wi-Fi anymore. Okay. Oh, we did it. I don't look good today, but
Oh, neither do I.
All right.
The longer we spend at home, the longer I'm just like, I'm here. I'm not getting fancy.
Yeah, I'm not leaving my home. Okay, so but I have a class with a bunch of MHA students later, and they're all always dressed up. I don't know why, but it's just like the culture of MHA versus MPH, I feel. Anywho, so I'm calling out object matrix ones from list example. So I did list underscore example brackets matrix underscore ones, and I got like my name over and over and over again 4 times. Is that right?
Yeah. No, so pull it up for me.
Okay. All right. Let's try. Ooh. She's in pharmacy school, so it's perfectly fine. Everyone in the building is having Wi-Fi issues, but we all. Oh.
I was happy people were able to come today. I was worried about there being power outages.
Yeah.
All right. So, okay. So if you look up at your list example, so where you define list example above number 3.
Uh-huh.
All right. So in the list call, notice that when you made list example, you renamed matrix underscore ones as matrix. Do you see that?
Yeah.
So when we call it from the list, we've got to call it as matrix.
As matrix.
Now, the other problem with this, I still don't think that'll run, but try that.
Okay.
Because.
Go away. All right, run it.
Yeah. So the problem here is when we call that element using the bracket notation, we can't give it the name, we need to give it the position. So see how matrix is the 3rd element in your list?
Yes.
So instead of matrix, we want to have the number 3 there. And then one other thing we need to change is that when you call elements from a matrix, we use single brackets. When we call elements from a list, we have to use double brackets.
Okay, and then, so let me put the double. Okay, and then the names, was it here? I don't know if you can see my mouse. That I need to fix it?
No, that should be fine.
Okay. Didn't you fix anything else?
Oh, but instead, remember that matrix is the 3rd element. So we don't call it by the name matrix, we give it the number 3.
Oh, number 3. Right?
Yeah.
Okay.
Try that.
Like we did in section 2. All right, run it. Oh, look at that.
There you go. So now you've got to write a second way to do the exact same thing.
Yes.
So another way is, how did we use the $ before when we wanted to call elements from a list?
$signs are used to identify parts of a list.
Yes.
So
do me a favor. So type out list underscore example.
And then we would put something.
So now do the $.
Okay.
And see what happens.
Instead of the arrow. I always put the arrow. Okay.
Now see, when you put that $, all 3 pieces automatically came up and it will autofill for you.
All right, let's do it. Run it. Wow.
There you
go. $signs are used to recall.
Exactly. And $signs are nice because if the objects either in your data frame or in your list have names to them, have names attached, then they'll auto populate after the $sign. You'll be able to see what all the options are.
Okay. Sounds good. I'm just going to keep my video on now. But I can't mute it. Oh, I should probably stop sharing with you.
All right, just so you know, so we've got 10 more minutes, but I also will have office hours on Monday as well. So if you get stuck and you want to look at it together, are you available 9 to 11 on Monday? Okay, I'll have office hours from 9 to 11 on Monday as well. Oh, you're muted. I do it all the time.
I was also listening to the class, so I did hear some corrections that you had made or some re-identifying, and I copied and pasted your stuff from the chat.
Oh, awesome. And I will post the video of this of the lab as well.
All right, sounds good.
Yeah. So once we get done today, it takes a while for it to, because where it's kind of a longer video, but it will be, I'll put it in the lab section as well. So you can always, fast forward to the different sections.
Sounds good. Like she knows when the video comes on. She's like, let's go see our favorite professor.
Oh, this is so sweet. At least she sits there and she's good while you're typing.
Yeah, she's good. She just knows when the video is on. She embarrassed me last time. It's a lot. It's a lot. In another class, and the teacher laughed because she paused the screen so it looked like she was asking a question, and I was like, this is too much.
That's really sweet though. You all probably figured out. I really love animals.
That's why I let her sit here, honestly. In my other classes, I'm like, you need to sit in your spot. And
all the animals can come into my class, and I'm perfectly fine with it.
Yeah.
I love them all equally. Yeah. Even the ones that aren't mine, I love them.
All right, find this.
It's been one of the few nice things about being on Zoom all the time is I get to see everyone's, their pets, and it makes it a little bit more personal, I feel like.
Yeah. Equal. I agree.
Lindley, how's the lab going? Did you get stuck again, or are you doing pretty good?
It's going well. I think I can get it done in 10 minutes, but I'd like you to take a look of my chunks and interpretation before I go. Would you mind me sharing the screen?
Oh, not at all. Go ahead. Yeah.
So, yeah, this is 1, 2.
Yep. Perfect.
3.
Yep, that looks great.
4.
Yep. No, these all look good.
5, 6.
Yep. No, I think that all
7.
looks
I
great.
haven't finished it, but I guess this takes the winner.
Yeah, no, what you've got there below that, that's exactly what you want there. So it's summarizing those 100 games to show who won.
Cool.
Yep, nope, that all looks great.
I guess I'm done for this class for this week.
I know, you're already done. It's only Thursday and you're already done for the class.
Oh my God, you have no idea how many papers and how many presentations I have in the following few days. Ah!
Oh, well, good. Well, at least this one's off your plate.
I love this class because I can just get it done within the day. Oh my God, this is my favorite class for this semester. I'm not going to tell the other people.
I'm hoping, since this is the first time I've ever taught this class, my hope and my dreams are that I get to teach it every semester. So.
Oh my God, I'm gonna recommend it to everyone in my program if you're going to do it.
So that way I can run it every semester. So, because like I said, this is the first time. Fingers crossed. I was shocked. At first I had 6 students in the class, and I was really excited with 6 students, and then we got up to 24, and I was beyond excited. So happy.
Well, you know what? I don't want this class to be too frequent because I want us to be special for you. You remember this time you have 24 students in the class, so you remember all of us like vividly. Every time you record the time you had in UK, oh my God, those 24 students.
Because you'll be my first one, so I'll base all other classes. Like nobody will be able to live up to your old standards.
Okay, I'll do the recommendation if they can ask.
Have a great weekend and good luck getting the rest of your class stuff done.
Thank you guys. You guys have a good weekend and see you guys next Thursday.
See you. Have a great day.
Yep.
Yeah, Christine, let's make sure that before we leave, we get that 3.2 done for you today.
Yes.
That way the only thing you'll have is the lab.
So I have, so I'm installing the package. I'm trying to remember how to do that. We did that before.
Yeah, and remember, you can either type the line of code or you can go up to tools, install packages as well.
Okay.
I tend to just do the button one where I go to tools, install packages.
Okay. Tools.
She says, Mom, it's time. You need to get off of here.
Yes. She is very, okay, packages met. It's MATLAB. She really likes routine. She knows we're getting close to playtime. All right, MATLAB. So I just do install packages and it will, here, I'll share my screen.
Yeah.
Dude, just share everything. Oh. So then you don't have to see my top 10 Taylor Swift picks. Sure. Okay. So
Careful, it's M-A-T, not M-E-T.
oh. M-A-T.
There you go.
It's this one. All right.
Yeah, if it ever doesn't auto-populate, you've probably got something spelled wrong or capitalized wrong.
Yeah.
There'll be occasionally stuff won't pop up, but for the most part, that'll help you catch stuff.
Oh, well, that's why I didn't run, because
And then don't forget, so okay, whenever we install a package, so after we run the .install packages, what's the next thing we always have to run for packages? There's another line of code that's always going to follow that. Starts with an L.
well, okay. If we install package.
So install, you can think of that as it puts it somewhere so R can use it, but we got to do something else to bring it forward. There's another call we've got to use.
Okay, so a $sign brings out calls from
So
a
it's not for an object. This will be, do you have the 3? Oh, you don't have the scripts open.
Oh, I do. It's over here. Oh, this script?
Yeah, so no, I was gonna say the one for the 3.2 notes. I think is it 3.2 or 3.3 notes? I can't even remember now.
I have the 3.2.
Yes, at the 3.2 script. So the notes for 3.2.
All right, this one. Oh, man. I'm sorry.
Oh, I think you got it's not showing on mine.
But I can look it up. So. All right, I'm gonna look it up. All right, well, while I look this up, my friends and I are ranking the top Taylor Swift songs, but we're ranking all of her songs. Because we all can't agree on what her best songs are, so we're just going to rank all of them. Okay.
I think it's very quantitative. And then what you could do is put all that information in the R. And then you could be like, look, I've analyzed the Taylor Swift songs. Here's the best one.
Yeah. I've created all of times, when these songs came out, when was her peak?
Yeah, exactly. You could find that using R.
Yeah. Okay, installing packages code in R code.
Yeah, it should be. So what I was looking for, stop sharing for a minute. I'll show you what I was, if you don't mind. And I'll let me show you where I was referencing
to. She's coming out with a new Fearless release today. Well, and she's releasing 5 more songs. So it went from being 125 songs to 130 songs.
That's a lot of songs. It's going to take you a while.
She's busy.
This is where I was talking about in the module 3.2 script. So this is what I was talking about.
What the heck, Christine? Okay, all right.
And so so this example for this, it's really similar to what I talked about at the very end of the 3.2 video.
Yes. Where was this in?
3.2. Yeah, it should be at the very end of the script.
Sorry.
No, you're good.
Run it.
So anytime you install a package, you are almost always going to run that library statement after it. So just think of them as being a pair almost. So you'll install the package and then you'll run the library function.
Okay.
Yeah, they'll pretty much always go hand in hand.
Okay, so now I've done this. And then it should, and then here, I'm going to go back to you. I'm coming. Zoom. Share screen. R. Share it. Okay, so where would it pop up?
Oh, it doesn't. It's just ready to use now.
Oh, it's just ready to use.
Yeah, so now you're going to run some matrix underscore ones. So that basically you're going to write the same code that you did for step 5, but you're going to get a different answer.
Oh. Oh.
Yeah,
Wow.
so and so have a look at that end of that 3.2, because that's what I was talking about there. You want to be careful because every once in a while when you install a package, it will override an existing function. And then to get rid of it, so step 9 shows you how to get rid of that and go back to what you had originally.
So write a comment about explain why the output from step 5 and step 7 differ from one another.
Mm-hmm.
So from my understanding of this, it's no longer looking at what we had it originally identify as matrix 1 and is now looking at our new data set, the new data that we put in.
So the data is not changing at all. So the matrix 1 is still the same. We haven't changed that at all. What's changing is the function changed. So the sum function is different from the MATLAB package versus the sum function we looked at earlier. So again, have a look at the end of that module 3.2 script. Like the answer is pretty much right there at the end of that script.
So sometimes I have it pulled up. I don't think you can see it though. So sometimes when you pull up new packages, these packages are designed differently.
Yes, well, they'll have functions inside of them that are different. So the base R has a sum function, but when we install the MATLAB package, it has a different sum function in it. So it kind of replaces the original one. And so it's something we want to be aware of. It doesn't, I've only had this cause problems a handful of times, but it's definitely something you want to be aware of.
Sorry, I know that it's probably time. The new package downloaded has a different.
Yeah, for some. So, and so at the bottom of that 3.2 script, there's a comment, and that comment pretty much is the answer.
I see the sum function that takes the sum of the entire matrix has the mask by a function written to reproduce the sum function in MATLAB.
Yep. So that's it. That is what's happening here.
Should I replace that with what?
Oh no, what you've got is fine too.
Okay.
I was just pointing out that we call that masking is what that's called.
Oh, okay. Well, I'm gonna write that right here. I'll write it so I remember. Oh. Run the line of code given below. Oh, wow.
Yeah, that one's the easy step.
It's already there. That's so nice. Okay. Find the sum of matrix 1. So now this code, this one right here, fixed maybe the problem.
Exactly.
Okay, so then we go sum and we say matrix underscore 1s. And then we're going to go like this. Run it. Oh my gosh, Zephyr, you're missing out on things. Okay, and write a comment on how to explain. Okay. Ooh. I will click it. Okay, I unclicked and then.
What's it doing? There it goes.
Sorry. So I'm assuming what this code did was it told it that we want to use the package, but we want to keep the functions that we have identified.
Actually, it goes a step further than that. It actually gets rid of the MATLAB package. So it's really what it's doing is it's reversing that library step that you did up above. And so now the matrix, the MATLAB package is no longer loaded.
So why would you, so what is the point of packages? Like, why would you want to download?
Yeah, so packages are, we'll use packages a lot in this course. So packages just contain extra functions that aren't in base R.
Okay.
And so most of the time, really, when you're working in R, there's going to be lots and lots of packages you need because we need extra stuff. It's just we want to be careful because occasionally that extra stuff might overwrite another function. And again, that rarely happens. It's just something you want to be aware of. So that's why I put it in here. But so for example, next week, we're going to start working with what's called the ggplot2 package and the tidyverse package.
Yes.
And they are some of the most commonly used packages when it comes to analyzing data. So there'll be lots and lots of packages that we use.
It reminds me of in Excel, like how you can pull up different toolboxes and like use different options, and then you can get rid of those to basically like minimize the amount that you'll be using. So it kind of reminds me of that a little bit.
No, that's good because that's a similar idea.
Okay, that makes sense. I also I by accident sent in, it says Vasquez PP 3_2, but it's really 3_1. I fixed it in my computer, but I just
that won't be a problem.
I by accident did that.
Yeah, because so when you all submit work, it's attached to your name. So so Ron actually grades the homeworks. When he opens it, he'll see that it's the script that matches that set of questions. So it should be perfectly fine.
Perfect. All right, so I'm sending it in. Thank you so much. I really appreciate it.
You're welcome. And like I said, and I'll be back Monday at 9 a.m. So if you have any trouble with the lab, feel free. And if something happens and that time doesn't work for you, just let me know. My Mondays are pretty open.
Okay, it should be fine because I don't have classes on Monday. And I see that in the announcements you put your office hours, so I will be there.
Sounds good. You have a great day.
Thank you so much for your time.
Oh, you're very welcome. Have a great weekend.
You too. Bye.